Hey, look up! There's a meteor shower happening right now! Okay, not really, but I made you look. If you're a fan of full moons, there's one coming up very soon, on February 27th to be exact. I really hope this video comes out in time. The moon will be lit up right in front of our eyes because it will be located on the opposite side of the Earth, where the sun is. It will help illuminate the moon, providing us with a night to remember. Take a good look at it. Doesn't it sort of resemble a huge snowball just hanging from the sky? Some native tribes in the northern hemisphere of our planet might have thought the same. That's why they used to call it the snow moon. You know, when it was big and full, like this. Okay, go ahead and grab a telescope now, because on the 9th and 10th of March, there are 3 planets that will line up for your aesthetical pleasure. Starting from top to bottom, you'll see Jupiter, then Saturn, and last but surely not least, Mercury. Now, depending on how good your telescope is, and if you've even got one, chances are you'll see some details of these 3 planets. You adjust your telescope a bit, and there it is, another planet. Almost like they're not thousands and thousands of miles away from each other. But that's not all. They'll be visible to the unaided eye too. This means you won't even need a telescope. Well, you'll probably see them like this, 3 bright white balls in the sky. Still astonishing though. You'll need to be looking at the southeast around half an hour before the sun rises, and voila, there they are. In the mood for a relaxing shower? How about a meteor shower instead? This time, you can keep your telescope safely stored, and you don't need to worry if you miss 1 or 2 of these showers, as there are quite a few happening this year. They're pretty evenly spread out too, and I don't mean the meteors. Those come close together. Grab your calendar and put a reminder on these months. You can choose from April, August, October, November, and December. Some months even have 2 showers instead of only 1, like October and November. Choose the month and day that works for you. Just check your calendar again. If you don't mind it being a bit chilly, just wrap yourself up in a blanket and hop in the back of your pickup truck. Then, all you have to do is stare up and enjoy the sky all night long, waiting for the shower to happen. Or, if you like to work by the clock, set up an alarm to wake you up in the middle of the night. That works too. Mercury's coming right at you! Watch out! Nah, don't fret. It's still right up there, just a bit closer than usual. That's because on the 17th of May, it'll be at its greatest eastern elongation. What this means is it will be easier to observe. Right after sunset, point your eyes to the skies in the west and try to look for the planet. This happens again during the 4th of July, but this time you'll have to look to the east. You might need a compass. Start your celebrations early in the morning, just before the sun rises, with a gorgeous view of Mercury, and of course a cup of coffee in your hand. If you still don't catch it then, try September 14th or October 25th. How about when the moon loses its natural white color? This happens just a few days after Mercury's first performance, on May 26th. It's called a total lunar eclipse. The moon will get gradually darker, as if someone was dropping dark red paint on it, until it finally reaches this sort of rusty red color that you can see on the screen. Not all of us will be able to see this unless you're on a cruise in the Pacific Ocean or in the calm fields of Eastern Asia. If you live next to the Tokyo Tower, you're in luck. It'll be visible throughout the whole of Japan. And if you happen to live in the western part of North America, you'll also be able to see the moon shapeshift. Well, not quite shapeshift. It's not going to turn into a wolf or anything. That only happens if you're a werewolf, which I definitely am not. So it's more like a color shift. Still, on the moon, picture a massive black hole. Well, this next astronomical event kind of resembles that. On June 10th, during the annular solar eclipse, the moon will be the furthest it ever gets from Earth. While it's doing this, it ends up covering most of the sun, leaving just a bit of its curvature for us to see. If you happen to look at the sky during this time, what you'll see is a massive ring of light. Chances are you won't be able to tell that's the moon out there, since it'll be the same color as deep space, the absence of color, or just a very deep black. Oh, And that ring you're seeing? That's the sunlight. Okay, since we're talking about rings, I've got one for you. Saturn's ring. This planet is the full package. It's a planet, it has a ring, and get ready for this, it has 82 moons. It feels like every year a few new ones pop up out of nowhere. Anyway, during August 2nd, the planet will be at its closest point to Earth, and the sun will help us catch a good sight of it by brightly illuminating it. Not only will it be brighter than it ever is during the whole year, but it will also be visible all night long. This is the time to get that telescope ready again. A medium-sized one should do the trick. That is, if you want to see its rings and some of its moons, the ones that shine the brightest. Another planet that's coming closer is Jupiter, this time on August 19th. The same thing that happened to Saturn will happen to it. The sun will shine bright on its big planet face. The only difference is that this time, if you have a good pair of binoculars lying around, you'll be able to see the planet's 4 largest moons. Although they'll look like tiny dots, but now you know what they really are. Okay, so you've been thinking about those meteor showers I mentioned earlier. Well, this one is the best there is. It's called the Perseids meteor shower, and it almost looks like the sky is a pitching machine, except it's pitching meteors. During this particular shower, you might even be able to observe up to 60 meteors per hour. They're very bright too. Look at them go! Zoom! There goes another one. The best days to get cozy, sit on the grass, and just lie there looking at the sky is during August 12th and 13th. Usually, when these 2 days come around, the sky's dark and clear, perfect for a meteor shower. Picture a slightly red moon. That's called the partial lunar eclipse, and it happens during the 19th of November. This same red moon will get darker and darker as it moves through Earth's shadow. It won't be visible to everyone though. Here's a globe. Let's mark the places where you can see this partial lunar eclipse. First, we got Eastern Eurasia, then Japan. The Pacific Ocean's included in this list too, but unless you got a boat, you're likely not going to be there. Then we've got North America, Mexico, Central America, and lastly, some parts of Western South Africa. Grab a hold of your eclipse glasses and get ready for this last one. It's the last solar eclipse of the year. This one in particular is the best one to catch, as the moon will block the sun for almost 2 minutes. You'll be able to see the almost ghost-like sun's corona, also known as its outer atmosphere. The sad part is, you'll have to be in Antarctica or the South Atlantic. Just be careful out there. I heard it gets a little chilly.
Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards.
When astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line, stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, the hole is way bigger than any existing star. It'd have to be 1,000,000 times more massive than our sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these two black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the two holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed, and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly, but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up. Not unlike a giant cosmic blinker, a supermassive black hole 570 million light-years away flares every 114 days. Recently, astronomers have noticed powerful eruptions of light coming from the hole. The monstrosity is about 20 times the mass of the one at the center of our home Milky Way galaxy. So far, the only explanation scientists have is the black hole is ripping chunks of matter out of an orbiting star. It happens every time it gets too close. This discovery is rather exotic because no one has ever seen a black hole do something like that before. Usually, if a star comes close to a black hole, the space monster shreds it into thin strands, like spaghetti. After that, the black hole swallows most of the star's matter. The remains arc away in long, bright streamers. But not in this case. Every time the star approaches the black hole, it loses about 3 times the mass of Jupiter, and that's the largest planet in our solar system. This also results in a tremendous flare that astronomers can see on Earth. The flares are so regular and consistent that the researchers managed to predict several of them. They happened on September 6th and December 26th, 2020. A nebula is a cloud of dust and gas in outer space. You can see it in the night sky, either as a bright patch or, vice versa, a dark spot against some glowing matter. The Red Rectangle Nebula in the constellation Monoceros, or the Unicorn, is unlike others. Our universe has very few straight lines, and here you are, looking at a giant rectangle, which is a huge gaseous nebula, no less. And then, there's also the color, a bizarre shade of orange-red. Astronomers suppose the glow might be coming from some unusual activity inside the dust clusters. This activity is likely to be going on at the molecular level. The universe is around 13.8 billion years old, but HD 140283, a star informally called Methuselah, is apparently more than 14 billion years old. Even more paradoxical, the star has some chemical elements that are more typical for a second-generation star. Those are the ones formed from dust and gas left after the explosion of the first generation of stars. And still, the main problem is, how can a star be older than the universe itself? So far, the most likely explanation is an error in observations. It could make astronomers believe the star is older than it is. The star called Vega is relatively close to us, a mere 25 light-years away from the Sun. It's not the most usual star out there. It's brighter than it's supposed to be, and it's not round, but rather egg-shaped. Astronomers claim that's because the star rotates so fast, its shape changes. See for yourself. It takes the Sun 27 days to make a rotation, and Vega needs only 12.5 hours to turn on its axis. This speed also influences the temperatures on the star's surface. Its poles are several thousand degrees hotter than the equator. There's a supermassive black hole 250 million light-years away from Earth. It produces the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. The Fermi bubbles confuse astronomers to no end. It's not every day that our home galaxy blows bubbles that are hotter than 7 million degrees Fahrenheit. Coming from the center of the Milky Way galaxy, the spheres are made up of nothing but powerful gamma rays. It would be a bit less strange should one bubble stay inside the other, with both of them at the center of the galaxy's core. But the two giant spheres hover independently above and below the black hole at the center of the Milky Way. Even more bizarre, they touch and form an hourglass shape. It makes the entire structure look like the number 8. The bubbles themselves are well defined and slightly sharp-edged. They're also breathtakingly enormous, spanning a total length of 50,000 light-years. Scientists have yet to crack several mysteries connected with the Fermi bubbles, like what can produce such extreme energy? It's as powerful as 100,000 exploding supernovae. Or what's with the off-center nature of the bubbles? Something must be going on there, even though it seems that the bubbles surround nothingness. K2-141b, a planet outside of our solar system, seems to be not that different from Earth. If you visited it, you'd see liquid oceans evaporating into the atmosphere. Just like on our home planet, the vapor then condenses and gets back to the surface as rain. But instead of water, all this happens with rock. The surface of the unusual exoplanet is covered with lava seas. In most places, they're tens of miles deep. And since the temperatures on the planet reach 5,000 degrees Fahrenheit during the day, the magma in the oceans vaporizes into the atmosphere. After that, supersonic winds, moving at a speed of 1 mile per second, carry the rock vapor to the planet's night side. There, the vaporized magma cools down, becomes liquid again, and falls to the surface as rocky rain. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in 2 days, 15 hours, which means it travels remarkably close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet has huge volumes of water ice, known as Ice X. It remains solid despite blistering temperatures. Neutrinos are teeny, almost massless particles that can move at nearly the speed of light. They can easily pass even through metals and travel miles and miles without anything to stop them. You can be sure that some neutrinos are passing through your body right now while you're watching this video. These elusive subatomic particles get born in supernova explosions and in nuclear reactions inside stars. About 4,000 light-years away from Earth, in the constellation of Serpens, there's a bizarre planet. Astronomers think it could once be the core of a massive star, long gone now. 5 times the size of Earth, it seems to be one enormous diamond. The planet is denser than any other discovered so far and is made up of mostly carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Most stars move around the center of their galaxies following fixed orbits, but not HE 0437-5439. This 30-million-year-old star that appeared not far from the center of the Milky Way decided to set off on a journey. Astronomers think the star might have come across the supermassive black hole Sagittarius A star, and the space monster might have pushed the star out of the galaxy. It's now traveling through the Milky Way's outer halo, moving right into interstellar space at a speed of 1,600,000 miles per hour. Stellar halos surround galaxies and are home to stars and star clusters. This discovery turned out to be extremely confusing. Such short-lived massive stars, because tens or even hundreds of millions of years is a very young age for a star, aren't usually found in the halo. There, you can only encounter the oldest stars in our galaxy, those that are at least 10 billion years old. When disastrous magnetic field collisions occur at the sun's equator, they cause ginormous tsunamis of plasma. These tsunamis move across the star's surface at a speed of 1,000 feet per second. Such a tsunami can last for weeks at a time. They happen almost every decade. More than 7,000 light-years away from Earth, there is the Eagle Nebula. It's a young cluster of stars, just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, towering tendrils of interstellar gas and dust. They're also a part of the nebula's active star-forming region. Newborn stars are hidden in these wispy columns. Unlike their supermassive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. But even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims tons of micro black holes could have appeared right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that several mini black holes pass through our planet every day, totally unnoticed. Scientists think white holes might exist, even though none has been found yet. When some space object comes across a white hole, it can't enter it from the outside, but light and matter can escape from within the hole. Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there will be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles. A group of underwater explorers stumbled upon a mysterious discovery in June 2011. It was a strange something resting deep under the freezing waters of the Gulf of Bothnia in the Baltic Sea region. The Baltic Sea anomaly, a weirdly shaped feature 210 feet long and 26 feet tall, was discovered 300 feet below the surface using sonar by OceanX. The team claimed that their electrical equipment stopped working when they got to within 650 feet of the mysterious object. Anything electric that was taken down just stopped working altogether over the site. Moving away from it let the electronics turn back on. It remains a mystery, but the unique shape leads to many claims that it could be part of a former sunken city like Atlantis, or even a mysterious object from outer space that crashed through the ice at some period. The scientists studied samples collected from around the site and determined that it could be a simple glacial deposit carved out from moving glaciers during one of the ice ages. The anomaly is just a piece that was left over, undisturbed for thousands of years. It hasn't been explored enough yet for a true answer. Off the southern tip of Japan lies the Yonaguni Formation. A local diver first noticed these formations in 1986 while searching for new dive sites for tourists. When he saw the large steps that resembled a pyramid, he decided he must have discovered an underwater city. Archaeologists believe that the structures belong to a long-forgotten fabled civilization, just like Atlantis, that had vanished beneath the waves thousands of years ago. Structures inside the pyramid that resemble stonework, like castles and a stadium, are connected by roads and what seems to be large walls all the way around. The marks in the stone show quarry work with faded faces and rocks sculptured into animals. But other experts say that the symmetry of the rocks is not as perfect as reported, and that it appears to be solid rock rather than carved blocks. For them, it's just a coincidence. Research is going on to determine if it's truly a lost civilization or nature just having a little fun. The Lincoln Memorial is gigantic in size, and the view of the reflecting pool mesmerizes visitors. For enthusiasts that love history, searching for the famous carved lettering mistake in the walls is also part of the journey. With high hope for the future, no prediction in regard to it ventured. Except the sculptor accidentally spelled future with an E instead of an F. There is a chamber in the building's foundation that's also worth a visit. You can even find a cave-like structure where stalactites form from the dripping water through the limestone through a secret door. There's graffiti from unknown construction workers on the supporting columns inside this cavernous space. Around the northern tip of Queensland, Australia, an uncommon cloud formation that rolls through at dawn scares the tourists. These clouds are called morning glory, a very rare type of cloud that seems to almost roll across the sky, looking like a massive tube. Measuring up to 600 miles long, this phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance. They believe the moist, cool air at the back of the clouds causes them to sink downward, almost dropping onto the land. In northeastern Thailand, 466 miles away from Bangkok, A 75 million year old rock formation sticks right out of the mountains and into the forest. Looking like a pod of whales swimming together, this place is called Three Whale Rock. Millions of years ago, this area was just a desert, but archaeological evidence from the Cretaceous period, when the T-Rex and Triceratops were out there, show that the land was changing quite dramatically at that time. It's believed that the sandstone mountains were lifted by plate tectonics and erosion by the Mekong River. It resulted in the strangely shaped rock formations that stand out today. Anyone willing to hike the network of trails can reach the place and find waterfalls, as well as a wide variety of plants and animals. From the very top of these huge monoliths, the beaches of Mekong, the mountains, and forests stretch in all directions. One of the most talked about books of the 20th century was an ancient text that no one could read. The Voynich manuscript was discovered in 1912 and is the world's most mysterious manuscript. Looks like it's withholding many secrets from the world. The handwriting inside is of an unknown language or code. It's heavily illustrated with strange pictures of unknown objects and zodiac symbols. The drawings of different plants are the most intriguing thing about the book, as none match any plant species on Earth that scientists are aware of. A professor of applied linguistics in England claimed to have deciphered some of the characters in the book, but as of yet, everything is still unintelligible. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they're not the same clouds that give us rain. These sprites occur at 30 to 50 miles above the ground, in the mesosphere. Artificial lights at night make it a lot more difficult to see this faint lightning, but it can be well over 30 miles wide. The red sprites are a type of cold plasma discharged above a thundercloud, turning red with the nitrogen in the atmosphere. They work as a balance of the lightning charges between storm clouds and the ground below. When freezing temperatures hit orchards in Michigan, the local early birds woke up to unusual ice sculptures hanging off tree branches. Ghost apples, perfectly formed ice apples. Finding one is very difficult, as everything has to be perfect for this to occur, and it's got to be freezing cold. This rare weather phenomenon causes the apples to freeze on the branch, with rain coating the apples in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Gateway Arch in the city of St. Louis is just like looking back in time. What most visitors don't know is that the arch also provides a glimpse back to its construction. The arch is the tallest national monument in the United States, standing at 630 feet high and 630 feet wide. It was built to withstand earthquakes and high winds and can sway up from 1 inch to 18 inches in a 20-mile-per-hour wind. It also contains the stories of over 700,000 people from St. Louis kept in a time capsule that was welded to the very top. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for you to see the phenomenal rings known as snow rollers. Starting with quite a thin layer of damp snow on the ground, it needs to sit on top of ice or powdered snow. Then, a strong enough breeze has to move a layer into a donut shape and gently start rolling down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind was blowing that day. A newly formed snow donut won't stay around for very long, as the dust is quite light. The Antikythera mechanism is a type of ancient computer that's baffling the scientific community with its extraordinary mechanics. A Greek ship sank off the coast of the island of Antikythera some 2,000 years ago. It was only discovered in 1900 by sponge divers. Archaeologists started sorting out the artifacts retrieved from the wreckage when they came across an object that didn't seem to fit into the time it was created. The machine seemed to follow time, the movement of stars, eclipses, moon phases, and even countdowns to events like the Olympics with amazing precision. No mechanism would come close to this until the 14th century, when they started building geared clocks in Europe. Archaeologists in Turkey believe they might have found the oldest known architectural construction in the world. It's over 10,000 years old, according to the experts. Found in ancient farming communities, these monolith pillars were up to 18 feet high. They were probably used for social events and rituals, but not much is known about them. Some of these large stone structures were human-shaped, with animal carvings and stone rings built into them. Recently, archaeologists have found rectangular buildings around the site. The communities that built these monuments were the start of the move into modern civilization.